Hey there everyone, Mr. Hayden here. The next section we're going to be doing in financial algebra has to do with income taxes. And to do that, we need to review linear functions. And linear functions are an important part of algebra, and you may see them on the AccuPlacer as well. So reviewing them will be good for those of you who will be taking the AccuPlacer. All right, so when you're looking at a linear function, you're looking at basically a line on the coordinate plane. And a couple characteristics about a linear function. The first big one is the slope of a line, and that's really measured by a ratio of the vertical change to the horizontal change, and also known as the slope of the line. It's usually referred to with the letter M, as you may remember. So M is really the change in y over the change in x. Sometimes you'll see it as delta y over delta x, and delta is the Greek letter that in mathematics and other fields typically means change. Rise over run, and if you have 2 points, it's the difference of the y coordinates over the difference of the x coordinates. Um, So the slope of a linear function is always a constant. In fact, that's the most important thing about lines, is that they always have the same slope, as opposed to exponential functions like what we're doing with graphing COVID cases in the US recently. And that line, or the slope, may be a positive, negative, real number, or zero, or even no slope. Uh, so in that case, you really have this, well, actually, instead of infinite, you'll often hear that the slope is undefined. And that the reason it is undefined is that if you use the slope formula, you're going to end up with division by 0, because x doesn't change no matter how much y changes. So the difference between x coordinates for 2 points on the line is always going to be 0. If you try to divide by 0, of course, that's undefined. Okay, so looking at the slope value, slope can be positive, and if it's positive, the line will go up from left to right. Okay, it can be negative, in which case it's going to go down from left to right. Okay, so as you move uh, down, the um, slope is going to be negative. All right, and then a couple special cases are the slope of a horizontal line. It's always 0, because no matter how much you change x, the change in y is always going to be 0, because it doesn't change. And if the slope is undefined, it means you have a perfectly vertical line. Okay, so the formula for finding the slope of two lines is, given 2 points, is you subtract the y values, and then you divide by the difference of the x values, which you subtract as well. So really, the surefire way to do it is to write x1, y1, and x2, y2. And it's important that you subtract in the same direction, both for both x's and y's. So I'm going to, for this point, the line that goes through these 2 points, it's going to be 3 minus negative 6 over negative 5 minus 5. So minus a negative number, of course, gives you a positive number. So this is going to give you negative 9/10. So the line that goes through those points is going to go down as you move from left to right across the x-axis. Okay, so let's do these other ones as well. This is going to be 3 minus negative 6 over 5 minus 5. So this is going to be undefined slope because it's going to be 9 divided by 0. You can't divide by 0, so you have undefined slope. And then the next one, let's see, negative 5 minus negative 5. So that's x1, y1 and x2, y2. So that's going to give you negative 10. And then negative 3 minus 3 is going to give you, let's see, negative 3 minus 3 is, actually, I'm sorry, negative 5 minus a negative 5 is going to give you 0. 0 divided by negative 6 is 0. Okay, so if you have, if you're asked to determine what the slope of a line is, and you can see you have 2 points. Actually, I think we're just going to skip that little next section. All right. Okay, so if you have the graph, you can just pick out 2 points and substitute those points into the slope formula and then simplify. So this line goes through 0, 0, and it looks like it goes through 2, negative 2. So to find the slope then, it's going to be negative 2 minus 0 over 2 minus 0. So that's going to give you negative 2 over 2. It's going to be a slope of negative 1. The next one, let's see, it looks like it goes through negative 1, negative 2, and let me see, possibly 2, and then 1, 2, 3, 4, 5, 6, 7. 2, 7. So I have negative 1, negative 2, and 2, 7. So I'm going to get, for slope, 7 minus negative 2 over 2 minus negative 1. That's going to give me 9 over 3, or slope of 3. And notice that is a steeper line than the slope of negative 1. So the bigger the magnitude, meaning if you ignore the negative signs for negative slope, the steeper the line is going to be. All right, let's move on here. Make sure I didn't miss anything on this page. Nope, I'm good on that one. Okay, we're going to skip that part. Let's see. I want to do continuous. Okay, so I'll just do a few more here. I can tell this is a horizontal line, so the slope's going to be 0. This one goes through negative 2, 0, and 0, negative 1. So when I use the slope formula, I get negative 1 minus 0 over 0 minus negative 2. So that's negative 1 over 2, or negative 1 half. And if you're computing slope, you should always look and make sure that the sign that you get corresponds to the direction that the line is going. So I would expect a negative slope value since the line, that line goes down as you move from left to right. Okay, so one of the most important or most well-remembered equation or formulas in Algebra 1 is the slope-intercept form of a line. This is one of the most important topics in Algebra 1, and that is y equals mx plus b. Okay, so m is the slope value, and b is, what is b? It's the y-coordinate of where the line crosses the y-axis. So that's how far up and down on the y-axis the line is when it intersects or crosses right through it. Now, vertical lines never cross the y-axis, so they have no b value, and their equation is a special case, which I'll get into in just a second. So if you're looking at the equation of a line, and if you want to pick out the slope and the intercept, the slope is the coefficient of x, and the intercept, even though it's the y-coordinate of the point, typically it's just considered to be the number itself. So this one would be slope of 1/2, intercept of 4. This would be slope of -2, intercept of 3, and this would be slope of 2/3, and it has no intercept, so it's really 0. And a point that has an intercept of 0 goes through the origin, or 0, 0 on the coordinate plane. Okay, a couple things about slope as well is the relationship of the slopes of parallel lines and perpendicular lines. So parallel lines actually will always have identical slope values. And parallel lines actually never intersect. So they'll have different intercepts, but their slope values will always be the same. And if you have a system of them, by the way, of equations of two parallel lines, you're going to get a solution of no solution at all, or an undefined solution, because they never intersect. All right, perpendicular lines, on the other hand, have slope values that are negative reciprocals of each other. So you change the sign and you flip the numerator and denominator. Okay, so if an example of that is 5 and -1/5, 6/5 and -5/6. So remember, the reciprocal of a whole number is 1 over that number, because you can really think of the whole number as being some whole number divided by 1. So when you flip the numerator and denominator, you get 1 over that number. Okay, so let's see, what do we have next? Okay, so if the question is, are two lines parallel or perpendicular, or neither? Well, you would just look at the slope values in the equations of the lines. So 3 and 2, not parallel because they're not the same, and they're not negative reciprocals. So that would be neither. This one is going to be parallel because they both have slopes of 1/2. This one is going to be perpendicular because -1 is actually the negative reciprocal of 1. So -1 is really 1 over 1. So the negative reciprocal of that is you would change the sign to make it positive and then flip the numerator and denominator. So you really still end up with 1 over 1, or just 1. So, and one important thing is, if there is no coefficient in front of x, it really means the coefficient is 1, so it will have a slope of 1. Or if it's just a minus sign, the equation will have a slope of -1. All right, so let's see where we are here. Okay, the most important thing, how to graph a line if you are given it in slope-intercept form. Now, there's actually also something referred to as the standard form of a line, which is ax plus by equals c. Generally, I think the algebra teachers here at the high school, when you're graphing a line, they usually want you to put it in slope-intercept form and graph it that way. There is another way. If you do have ax plus by equals c, you can graph it using by finding the x and y intercepts, where you substitute 0 in for y and solve for x, or substitute 0 in for x and solve for y. I'm just going to stick with the slope-intercept form of a line because that's the most common and universal way of graphing a line. Okay, so graphing the lines. Well, first of all, you need to pick out two things. You need to pick out the slope and you need to pick out the y-intercept. Okay, so for y equals x plus 5, the slope is going to be 1. So that's m, and the intercept is 5. So that means the equation, well, when I graph it then, I go to the y-intercept, okay, and then I turn the slope into, I write it as the rise over the run. So I write the slope as a fraction if it isn't a fraction already, and I count rise over run. Okay, so for rise, which is the numerator, positive means go up and negative means go down. And for the run, positive means go to the right and negative means go to the left. So in this case, I have a slope of a positive 1 over positive 1. So that means go up 1 and then go to the right 1. So you kind of count your way into making a right triangle to get the second point of the line. So I start at the y-intercept and I go up by 1 and over by 1 to get the next point. And once you have 2 points on a line, you can make the line just by connecting the dots. Since the slope never changes, 2 points is sufficient for graphing a line. So that's the way to graph a line that is in slope-intercept form. Let's do another one. So this would be a slope of 3 and a y-intercept of -5. So I'm going to go to -5 on the y-axis. Okay, so a slope of 3 is 3 over 1, and that is up 3 and to the right 1. So I'm going to go 1, 2, 3 to the right 1. And then I'm going to connect the dots. Okay, let's see. Okay, so this one is, once again, the slope would be 3/2. The y-intercept is 3. Go to 3 on the y-axis. Go slope of positive 3 over positive 2 means go up 3 and to the right 2. So I'm going to go 1, 2, 3, 1, 2. Then I'm going to connect the dots. All right, and then the next one has a slope of -5/3. So -5/3 is down 5 to the right 3, and my y-intercept is -3. So I start at -3, I go down 5 into the right 3. Now, if you're your next point is gonna be off the graph, like it will be in this case, if I count down 5 and up 3, you really going down into the right 3 is actually, you can also go up 5 and to the left 3. So essentially that makes -5 over -3, but that's really the same thing as 5/3, right? Because the negative signs would cancel each other out. So what happens is you're just finding a point going the other direction, but you're still finding a point on the line. So I'm going to go 1, 2, 3, 4, 5, and 1, 2, 3, and then I'm going to connect the dots with a line. Okay, special cases, the graph of a horizontal line the equation of it is always y equals some number where the number is a constant. Has to be a real number. Um, Equation of a vertical line, I should say equation, is always x equals a number. And once again, a number is a constant. Has to be a real number as well. We're not going to get into imaginary numbers in this class. Obviously, there are no imaginary dollars, so we're going to steer clear of that one. Okay, so some people think, oh, a horizontal line, the x-axis is horizontal. Wouldn't it make sense for the equation of it to be x equals a number? I would tend to think that. However, it's the exact opposite. You see a horizontal line, even though the x-axis goes in a horizontal direction, the equation is always y equals some number. And that number is equal to the y-intercept. So the equation of this line right here would be y equals 10, 2, because it goes through 2 on the x-axis or y-axis. And the equation of this blue line here would be x equals 2. So for vertical lines, whatever number it is, it's the point at which the line crosses the x-axis. Okay, so if I'm asked to graph those lines, x equals -2, technically it's not a function, but it still is a relationship between x and y, and that is x never changes no matter what y is. So every point that has an x coordinate of -2 is going to satisfy that equation. So so the graph of it would just be the vertical line going through -2 on the x-axis. All right, and y equals -2 is going to be a horizontal line that goes through -2 on the y-axis. Wow, can't even draw a line with my line tool. Pitiful. Okay, so one of the most important ways to graph a line is when you know, or I'm sorry, to write the equation of a line is when you know the point slope, or when you know one point and the slope. And then also writing the equation of a line knowing 2 points, also extremely helpful. Okay, so the formula for the point slope form of a line, oh, I keep hitting, I see what I keep doing, is y minus y1 equals m times x minus x1. Okay, so let's look at the three forms of a line. By far, the slope-intercept form is the most important. If you remember one thing from this, please remember the slope-intercept form of a line, of the equation of a line, I should say. This is the standard form, as I just went over. And this is referred to as the point slope form because you need a point and the slope. For slope intercept, you need a slope and the intercept. So it's pretty straightforward with the names of slope intercept and point slope form of a line. Okay, so the question then is, let's see, writing the equation of a line. First of all, how do you get something in slope-intercept form? Well, you solve for y. So essentially you're moving everything to the right side of the equation. So in this first problem, I would want to move the -3x over to the right. So that's going to give me 5y equals negative 3x minus 4. And then lastly, I'm going to divide by the coefficient. Now, when you divide by the coefficient, you have to divide both the x term and the constant as well. So the 5's cross out. I get y equals negative 3/5 x minus 4/5. And then for this one, I'm going to subtract 4x and divide by negative 5. Divide by negative 5 once again. And I get y equals 4/5 x minus 2. All right. So next we have writing the slope-intercept form of a line when you have the point-slope form. Okay, well, once again, you're solving for y to get the slope-intercept form. Doesn't matter what the equation looks like originally. If it's a line, you can always rewrite it in slope-intercept form. Always the most helpful for trying to graph a line. Okay, so to do that, I'm going to have to distribute the 5 halves here and then add 5. So I'm going to get y equals negative 5 halves x, and then negative 4 times 5 halves is going to give me minus 2, because 5 halves times negative 4 is negative 20 over 2, which is just let's see. I'm sorry, 5 halves times 4 is not negative 2, it is negative 10. That's more like it. Okay, and lastly, I'm going to add the 5 to both sides. And I get y equals negative 5 halves x minus 5. Alrighty, let's see. Moving on, I think I'm almost done. I'm just going to skip over the next example. Okay, so writing the equation of the line, if you're given different kinds of information, it may be easier to do it one way than the other. So frequently you'll know the slope and a point. Obviously you just use the point slope form because a slope and the point, you substitute the values into the point slope form, which is y equals y1 equals m times x minus x1. Any 2 points on the line, this is an important one to be able to do, and the graph of the line itself. Okay, so if you know point and the slope value, you substitute the point's coordinates in for x1 and y1 and the slope value in for m, and then rewrite it in that equation that you get in slope-intercept form, which is pretty much what I just did. Okay, we are given let's see, the examples I did on the other side, on the other page. Ooh, let's see, did I skip something? Oh yeah, I did special cases. Okay, and let me go back to this side of the page. All right, so point slope form of the equation for the point that goes through 1, negative 5 with a slope of negative 6 is going to be y minus negative 5 equals negative 6 times x minus 1. So it's going to give you y plus 5 equals, and then it would be negative 6x plus 6. Then I would subtract 5 from both sides, and I would end up with y, oops, y equals negative 6x plus 1. Let me zoom out and make sure I'm not skipping over some stuff. Let's see. Yeah, I did that. Okay, I guess I'm fine. I thought I'd skip something, but I guess I didn't. Okay, 2 points, given 2 points. All right, so the strategy here is to figure out the slope, and then use one of the points and the slope to write the equation in point-slope form, and then finally convert that into slope-intercept form. So this is one of the more complicated things to do in Algebra 1 at least, but you guys are far past Algebra 1, so hopefully this is manageable. Alrighty, let's look. So the first thing I want to do is find the slope. So the slope here is going to be the difference of the y's over the difference of the x's. So that would be 0 minus 4 over negative 3 minus, once again, 4 minus negative 3. So that gives me negative 4 over 4 minus negative 3 is 7. So that is my slope value. I'm going to use the 0.40, and the slope value of m equals, my pen's acting a little funky right now. So let me go a little slower, maybe write a little larger. So I'm going to do y minus 0 equals negative 4/7 x minus 4. All right, then I'm going to put that in slope-intercept form. Well, fortunately the 0 disappears, and I just have to distribute the negative 4/7. Okay, so negative 4/7 times negative 4 is going to give me 16 over 7. All right. And I think that's probably the most important points. I'm just going to oh yeah, the last thing, writing the equation given the graph. Okay, so there's 2 approaches. One approach is to find 2 points, the coordinates of them, find the slope like we did in the very beginning, and then use one of the points in the point-slope form. The other equation is to pick out the slope and figure out what the y-intercept is, and then write it right into slope-intercept form. So usually that's the faster approach if it's obvious where the y-intercept and slope is. So to find the slope of a line, you can, of course, write the coordinates of 2 points and use the slope equation, or you can count rise over run and just figure out what it is by kind of counting it as you move from one point of the line that's on the left to another point on the line that's in the positive direction on the x-axis. I always go in that order. You can go starting from the point that's farther to the right and go in the reverse direction, doing the point that's to the left. I usually like doing, and why do I keep having this problem? Okay, so for this one right here, I'm going to count rise over run, and really you're making a right triangle to get to the next point. So I always start at the one on the left, and in this case I have to go down 1, 2, 3, 4, 5. So that's a rise of negative 5 over a run of 1, 2, 3, 3. So m equals negative 5/3. And the intercept here is negative 3. So I would get y equals negative 5/3 x minus 3. All right, the rest of this is kind of just variations of what I've already been doing. So I've been rattling on here for probably 20 minutes or more. So I'm just going to call it a day, and then hopefully that's enough info for you. I'm going to have short homework assignments over the next week with graphing lines and linear functions. And then after we get back from spring break, if we have one, and I'm actually hoping we won't, I'm hoping that we just have 4-day weeks the rest of as long as we're out of school. Um, but after next week, we'll definitely get into the income taxes and how to relate those in terms of algebraic equations. All right, hope this was helpful, and we will see you later.